Hey, calculus. Welcome to our class today. I will teach you how solve problems using derivative of polynomials, and exponential function. All right. So we have some idea here, like when I'm in this derivative of a constant function. So what is a derivative of a constant function? We write it like this. Differential of divided by differential x of constant c, it will be equals 0. Okay, 0. That's the main point. So another idea that we have to remember when we working with the problems with derivatives of polynomials, we have to know what is a power function. Power function. Okay, what I mean this power function? A function like of f of x equals x to the n power, where n, so the exponent n is a positive integer. All right. It's if n, for instance, if n is equals 1, let's give it numbers. If n is equals 1, the graph of f of x equals x is the line y equals x. All right, and then a slope equals 1. So let's make the picture. This is the description in words. So now see, let me show you the graph, how the graph looks. If we make a picture about the graph, it will look like this. Look at we have 0 right here, we have x, we have y. So let's do the graph. So if the graph is like exactly like this, in the center, in the middle, so this side is y equals x. All right, and then the slope is equals 1. Right, this is our graph. Our graph is differential of the dx x equals 1. This is the picture. This is the graph. Okay, that's explaining the concept that I gave it to you before. Okay, let's let me erase this and then go explaining more ideas about this. We have cases like let's write like n equals 2 and n equals 3. So just write the formula, d divided by dx of x to the second power, and I mean this is the second power, will be equals 2x, right? And then the other one, we have d divided by dx of x to the third power. So that will be x, 3x, 3. Here is 2. Now here 3x with the second power, right? With the second power. See the difference? All right. So for let's let me give you another example. We're talking about the power or function. Power or function. Let's write for n equals 4. I will solve another problem. We find the derivative. We have to find the derivative of f of x equals x to the fourth power. All right. As follows. So just we have to write here f. Let me use another color here. F, this is the derivative. You write this sign. I mean the derivative of x equals limit. We have to write limit of f of x plus h minus f of x divided by h when h approaches to 0. So this will be equals to limit, all right, of what? Limit of x plus h to the 4th power minus x to the 4th power divided by h when h approaches to 0. All right, that's the first step. Second step, we will have just simplify our problem right here. So again, so limit of what? Limit of, now simplify our problem here. So we are here right now, right? So let's go and then write x to the 4th power, right? Plus, look at this, 4x to the 3rd power h plus 6x to the 2nd power h to the 2nd power, all right? So this is a decrease, the x will be decreased, and then h will be increased. The variable h increase. So now plus 4 h for, of course, h to the 1st power, and no, x to the 1st power, h to the 3rd power right there, right? Plus h to the 4th power minus x to the 4th power divided by h when h approaches to 0, of course. All right, so next step, we will have limit here. Now simplify all this. So now we will have here, you simplify all term on top. Here we will have 4x to the 3rd power h plus, okay, plus 6h to the 2nd power h to the 2nd power plus 4xh to the 3rd power here third power minus h to the fourth power divided by h when h approaches to 0. So next, here almost done. So simplify that. So limit of, now open parentheses, just write 4x to the third power plus 6x to the second power h only to the first power plus 4xh, right, to the second power minus h to the second power, right, close parenthesis. This is, you simplify all those, we will have 4x to the third power, right? So that's so in our conclusion, that's d is d divided by dx of x to the fourth power. That was our problem here, right here. This equals like 4x to the third power, right? So that's it. So let's let me explain it another concept belong to this topic: derivative of polynomials and exponential function. Okay. So next concept, idea, the next property, the power rule. If n is a positive in positive integers, then we have our formula like this. Formula will be equals b or differential. This is differential of divided by differential x, or d divided by dx, x to the n power. And that's equals that will be equals n x to the n minus 1. That's another rules. So with this, let me give it to you some examples. So example number 1, let's work with that example or problem. Let's write a problem 1. Number 1. So this called this part differentiated. Okay, and then let's write, if for instance number 1, number or 8, a problem 8, if for instance if we have f of x equals x to the 6th power, right? Then I mean the differentiated is f, just write a comma right here, of x will be 6x to the 5th power. See, we have it here. So this is this comma mean that they differentiated. Okay. Let's write another example. For instance, if we have if of x equals x to the 1000, power, 1000 power. So then we have, you are able to write it like this, y equals, y prime, or this little comma on top. Will be equals 1000, of course, write 1000 here, and then what else? You write the x and 90, 90, 90. 999. Okay. Let's go another one more. If we have f of x t to the equals t to the 4th power, then you are able to write like this: dy divided by dx. It's another way too. Di will be equals 4t to the 3rd power. Right? Another one. We have if we have f of x equals r to the 3rd power. So then let me I will to write it in another way, different way. Let's write it this way, not like that. So we have d. It's another way. So we have d. Just write d divided by dr. Okay, and then dr is equals r to the 3rd power. So immediately here you get the answer right there. So you don't need to write all this process. So right here you have it, the d divided by dr. So will be here 3 2. See, this is another way to, you see how write the problem, right? So this is problem 1. So like this example, this is like examples, okay? Let me write another problem. Like now, this is a real problem. So number 2, problem. Let's write problem 2. Let's write one question here. So this now we have to work with differentiated. Okay, so we have a, and a is f of x equals 1 divided by x to the 2nd power. Okay, and b, 2 problems here. B, let's go to f of x. Let's write it equals cube root of x to the 2nd power. That's it. What is the solution of this problem? Solution. Okay, let's see the step for the solution of our problem. So in each case that we have here, each case we have to rewrite the function, right, as a power of the x. So yeah, rewrite. Let's write here, rewrite as a power of x. So this is the one of the step. So we have to rewrite the solution. So since problem 1 here we have since f of x here is a problem A. Okay, f of x is equals, how do you write this as a power of the x? C equals x to the negative power negative 2, okay? Negative 2 to the x to the negative 2, right? In this case, we use the power rule. The power rule that explained it, that is explained before power rule, is with n is equals here, and this means n is equals negative 2, right? In the power rule here. That's why I write it like that. Okay, so try to the next development of all process. We have like this. Remember, we have to able to write f prime of x equals differential. I mean d divided by dx of x minus 2 to the negative 2 power. See, equals, this will be equals, and now 2x, see, 2x, right? Minus to the negative 2 minus 1, the power. All right. So if we simplify, we have to simplify that. We will have negative 2x here to the, you add these two exponents, negative 3, right? So if we continue simplifying, making it smaller, this will be equals 2 divided by x to the third power, x to the third power, right? So that's it. This is the solution, the first one. The second one, we have to write b. Just write b right here. So write this is our problem here. So write dy divided by dx, yeah, equals, this is equals d divided by dx. Okay, it is the same. So just write the parentheses. We have q root of x, cube root of x, right? Like this, right? Then we will have here will be equals d divided by dx of, so this is to the second power. Yeah, I made a mistake right there, missing the number. So here we will have x divided by to the 2 to the third power, 2 to the third power exponent. Okay, this is equals, we try to simplify, we will have 2 third x to the 2 to the third power, 2 thirds minus 1. So our conclusion there will be equals, just write 3, 2 thirds x to the negative 1/3 power, right? This is our second problem solution of our second problem. All right, it's just work with the differentiated problem. So let me erase this problem, and then I will show you another one, the solution of another part using this kind of using the power rule, right? Problem number 3. Let's write another problem. Problem 3. Let me try to solve this problem. This problem, we have to find the tangent. Look at this. Find the tangent. It's a problem. Or find the equation. Let's find the equation. Find the equation. You have to find the equation of the tangent line and the normal line. So tangent is one concept, and the normal line in both lines to the curve this is our problem from this question. Y equals x to the square root of x at the point let's write 1, 1. Okay, at this point. Okay, the solution. What is the solution to this problem? Okay, let's find the solution. It's a little bit longer. Okay, the solution. Let's write here. We have all the data right here. So f of x equals this one. F of x is equals x square root x. Okay, this is will be equals, we change x times x to the one half power. So equals x, then 3 half power. So then is now the prime. Remember, write the prime f of x. I mean the derivative here will be equals 3 half x of the exponent 3 half minus 1. See, simplify this. 3 half x to the 1 half. All right, 1 half right here. See, and then you simplify this. Smaller 3 half square root x. Right there, you have it. So the slope here, and this problem, the slope of this slope of a tangent at 1.1 1,1. So it is let's write it here. The slope at the tangent. So we are talking about 1,1 right there. Is f prime of 1 equals 3 half. See? So therefore, so the question of the tangent, there's the question. Where is the question of the tangent line? Is 1. we are looking for the equation of the tangent line. It is, so let me use a red color here. Y minus 1 equals 3/2, with all this information here, 3/2 times x minus 1, or we have two, or it is the same. Y equals 3/2 x minus 1/2. That's the tangent line. The tangent line. So now let's find. We are asking for, this is the tangent line equation. So now the normal line equation. So the normal line equation, let me erase it here, and then let's write it. I will keep with this data because now we are looking for the normal line. So now we are looking for the normal line. So this line is a perpendicular to a tangent line. Okay, that's our one concept. It's a perpendicular to the tangent line. So the slope here, so then the slope will be reciprocal. Then it's a perpendicular, so the slope is reciprocal. Is reciprocal. Is reciprocal to which number? Reciprocal, because this is the slope right here. Reciprocal to 3/2, right? 3/2 right here. That says the slope. So will be negative 3/2. So negative. So now our the normal line, then we have here x minus 1 equals negative, I told you, negative 3/2 x minus 1, because the line is a perpendicular, right? Or this is the normal line. Y equals negative 3/2 x plus 5/2. No, this is not 5/2. It will be 5/3. 5/3. All right. So that's the line. Let me show you in a picture. I will erase it all this, and then I will make a picture about this problem. Make a graph. So I make a picture about a little graph right here, and this problem. See, this is my right line here, and then here we have negative 1. So it's negative 1 right here, and then right here 3, and then this is 3. So the line, we have some line right here. The graph is like this, something like that. Then I may use the green color, and then one line. I mean, this is a tangent. running like this. Also like that. So this is a tangent line. This is tangent. That's the tangent. And then the normal is running is perpendicular to that line. So it's perpendicular. It's not great. So it's not very good. But something like this, right? That's tangent to the graph, right? So this line, this is the tangent, this is the normal. That's the normal line, okay, in our graph. So okay, now let's go to another kind of problem belong to derivatives of polynomial and exponential function. This code, now we have new derivative from O. Okay, we have some kind of rules we call the constant multiple rule. That's the property. So the constant of the multiple rule is the problem like this: d divided by dx, and then we have our constant right here, f of x equals c d divided by x f of x. Okay, that's the rules. So let me show you a problem here. So problem. Let's try, let me show one problem applying this kind of the rule. Our problem is two problems. We have number one, d divided by dx of 3x to the 4th power. So we have, this is our problem. So here will be equals 3, applying this rule, 3d divided by dx, okay, times x to the 4th power. Okay, so if you simplify that, applying that rule, we will have here 3, so the constant, and then we will have 4x to the 3rd power, right there. And then simplify will be equals 12x third. That's it, very, very simple, right? Let's write another one, another simple problem. We have d divided by dx of negative x. So this is our problem here. Applying that kind of rule, we will have d divided by dx, okay, of negative 1 here times x cross cochetes, and then equals. Here we will have negative 1, of course, right there. See? Here times d divided by dx, differential of x. Here times x. You simplify that. This is very simple problem. It's not big deal, right? Very easy. So here we will have negative 1 times 1 Easy, right? The answer is -1. See, that's it. Very, very easy question. Okay, let me show you one more question using a new derivative from all the constant multiple rules. Okay, now apply another kind of properties. The sum rule. Now we will have the sum rule. It's another one. The sum or addition rule. So the addition rule, we have the addition rule and the differentiation rule. So here you write a question like this. This is very simple. D divided by dx, open quotations. We will have f of x here plus g of x. It's a sum, it's addition. Okay, very, very easy. Equals d divided by x, f of x here, plus same thing, dx, right, of g of x. See, it's addition. Let's, and then this is the sum. Let's write the differential. It's another one, another concept, the difference. It is the same thing, just use the negative, we have to use the negative sign. But it is exactly the same. Just right here, d divided by dx square f of x minus g of x, right? It is the same thing. Here equals d divided by, but when you write the numbers, sometimes we get confused. So f minus d divided by x g of x. See, it's very simple. Just simplify the formula. It's like this is like the formula. Let me give you some examples. Let me write one problem here. So this color. And write a problem. I'm going to hopefully get enough space right here. D divided by x. So this is our problem here. Let me look at this. We have x to the a power plus 12x to the 5th power minus 4x to the 4th power plus 10 to the x to the 3rd power minus 6x plus 5. So this addition. So just we have to add everything together. Like in the first one, just write it one by one by one. So this will be equals here. Let's write d divided by dx here. The first one, x to the a power plus now 12 to the x to the 5th power minus 4 times x to the 4th power minus 10 right here, 10x to the 3rd power, everything. But as well, let me write the d because I skip it, but it's better. We have to write the formula there here. Otherwise, it's not complete. So now here, like the formula 12. So d. So we need to follow the direction here exactly. Yeah, times x 5th power, right? Minus 4, and then we have to write d d divided by dx and the 4 times x to the 4 power, right? Yeah, because I avoid that, but we have to write it. Plus now 10 d divided by x to the 3rd power. So just write there. Minus 6 and then dx times 2x, right? Plus we have, and then the last one, d. We don't have any, just write dx 5 times 5. Now simplify. You have to simplify here. 2 more steps here. Oh, it's a long. But it's good to just keep in your mind. Don't lose, because it's a lot. So right, the first one we will have in the first answer 8 to the x to the 7th power. All right. Plus now 12, 5 x to the 4th power. Minus, here we have 4 times 4x to the 3rd power. Plus 10 to the 3x to the 2nd power. Minus 6 times 1. Times 1 plus 0. Okay, that's it. So the last step, so simplifying all these, continue simplifying, smaller and more. So 8 to the x to the 7th power. That's it. Plus 12 times 5. 12 times 5, we will have 60. 60x to the 4th power. Minus here, 4 times 4 is negative 16x to the 3rd power. Plus 10 times 3, very easy, 30x to the 2nd power. Minus, of course, times negative 6 times 1 is negative 6 plus 0. That is the answer. So this is our answer in that problem, all right? All right. So good to now. So let's let me go another concept that we have to know in when we working on this topic. Another concept is exponential function. Exponential function. So we have to compute or compute the exponent, the derivative or the exponential function. For instance, if we have f of x like that equals here b to the x power. On using the derivatives, we have to use the derivative, and then we use the derivative. When you use the derivative, you write f prime of x, right, equals limit the let's remember from long time ago, f of x plus h minus f of x. We are talking about this divided by h when h approaches to 0. So again, equals here limit of we have here b we are talking about b to the x plus h, c minus b to the x power divided by h when h approaches to 0. Okay, that's our formula. If we simplify this, we will have we need to simplify our problems here. We will have limit of b to the x power b to the h minus b to the x divided by h when h approaches to 0 equals limit. We have here, we will have here b to the x power times b to the h minus 1 divided by h when h approaches to 0. That's the formula. That's the rule. It's a property, okay? So in a way of the conclusion, some little change right here. We will have f prime of x equals, for instance, b to the second power. Let's write it like this now with the number. We will have limit of b to the h power minus 1 divided by h when h approaches to 0, right? So the limit here we have here limit. That's a formula, okay? We will have b to the n power minus 1 when h approaches to 0. So of course, this is divided by h. This is f prime, or I mean the derivative of 0, right? So in the conclusion, when we have here like that, again, let me write with this f to the f of x equals b to the x. This is explanation before. Justify. We will have here f, I mean the derivative of x equals f prime, or derivative of 0 b to the x power. Some kind of rules. All right, that's very important because I will explain it to you. I will write some problems using these rules, these properties. Okay, another property that I would like to remember is the definition of the number. Very important, definition of the number. Definition of the number e. This is very common in algebra. So e is a number. It's a number such that we have a limit here. Well, I will write like limit of just write e to the h power minus 1. That's why I explained it before, the process before. I explained it to you, that coming from that process. Right now, here, divided by h, when h approach to 0, this is equals 1. This is kind of rule. So another rule, this is one. Another property important, remember, is derivative of the natural exponential function. Exponential function. So how write the derivative of the exponential function? We have this like this: d divided by dx. E we have this way: e to the x power is equals e to the x power. All right. So let me solve one problem using all these these two properties, these two rules, these two properties. I will erase it because I need a space. Okay, I will erase. Keep in mind this rule. Okay, these properties, and then I will erase it all these because I'm going to show you one problem. So problem. Let's solve a problem. What is our problem? Let's write if f of x equals e to the x power minus x. Look at the problem. We have to find f prime of the derivative and then also f a second derivative first and then a second. And then compare the graph. So also we have to make a picture of the graph of this problem, all right? The graph of f and f. So f prime and then a b prime. So okay, the solution, let me write the solution right here. It's very simple, okay, no problems. That is the solution to our problem. So here, of course, we have to use what problem? You have the sign right here. We have to use the difference rule. I explained it to you. I write this rule, okay? So we have to use that rule. So then we have here f prime of x. So write d divided by dx of this is our problem, e to the x power minus x. Okay, so this will be equals d divided by dx. Then now we have to write here which number here. So e to the x power, right? X to the x power, e to the x power minus the, remember, d divided by dx times x. So that's equals, we solve the problem. It will be equals very easy, simple. It's no problem right here. Simple. That's the answer. Okay. Second derivative. This is the first derivative, the first one. So now second derivative. Second derivative. And then we write it f(1, 2). Okay. That's mean the second derivative. So of x equals d divided by dx times e to the x power minus x. Okay, it's immediately that one. So equals d divided by dx. Here we have to write also e to the x power. Right, that's the second. Minus d divided by x dx times 1. Times 1, right? Equals, so now times 1, right? Here is times x, now times 1. See, the answer is e to the x power. See, that's the solution to our problem. If it says comparing the graph, also we have to make, let me show the graph. Keep your eyes right here. See the solution? Very simple. It's not complex. Very simple. Just follow the rules. I am trying to apply the rule that I explained to you before. Okay. Now let's make the graph. Okay. Compare the graph. So can make a little square right here. make a picture about my graph. So my graph is like this. So here we have a -1 and -1 right here, 0.5, 1.5 right here, and then 3. I want to make some graph right here. So like that. Okay, this is one graph, and the other graph is running like this. Okay, which one is one? This is F. And then the red one, this is F. The first derivative, okay? First derivative. So the graph looks like that. That's it. That was our class for today. Derivative of polynomials and exponential function. Our class was about a lot of rules, a lot of properties that we continue using in this topic. We have more examples, more problems coming in the next class using derivatives of the polynomials and exponential functions. Very important to remember all properties I show you today. All right.